Hi, I'm Kishan Gounder, and before I'm starting this presentation, I would like to send my warm greetings to Dr. Musli bin Mohammed. And here goes our project title, which is Productivity Improvement Based Line Balancing in Pasteurized Milk Manufacturer. So I would like to introduce my group members, me myself, Kishan Gounder Analaki Supaya, followed by Liu Junxian and Kavinesh Analaki Francis Toby, and also Kishan Kumar Dharmalingam. So moving on to our presentation is by introduction. Okay, when we take a look at the problem statement, with the existence of multiple workstations in the production line, the time taken to complete one product differs due to certain workstations being monitored manually for quality checks. Hence, to further optimize the efficiency of the production line, a fully automated system should be implemented where it is operated by a minimal number of workers. The standard level of the pasteurized milk per pack varies is not fixed. In every pack makes the standard mass of the product is not constant due to error in electron beam. The current production efficiency for small and medium-sized milk plant was lower, and it implied that there were waiting times which are considered wasteful and result in high production costs. Following to the objectives, the objectives are to investigate the efficiency of the work process and also to reduce the unnecessary resource allocation. Moving on to the project scope, the study focused on comprehending the concepts and methods of line balancing along with figuring out ways to increase a production line's output. Additionally, steps will be taken to optimize the duration at every workstation for constant refinement. Thank you.
Now I'm going to talk about the literature review. First is the background. Based on the comprehensive review of the literature, it mentioned that the efficiency of pastoral milk product in small and medium-sized dairy plant is currently less than 70%. This means that there are waiting times and lead to increased production costs. Three improvement models are proposed, which are reducing unnecessary resources, increasing efficiency, and implementary ECRS concept. In a food process plant, production cycle time depends on worker speed, machine speed, and conveyor belt speed. On an assembly line, there are several workstations composed of specific tasks to minimize labor or maximize output rates. In a labor-intensive production process, task time is uncertain and depends on each employer's skill, worker environments, and physical level. Then, to reduce the latency at other sites other than bottleneck, site can implement a ECRS concept, namely elimination, combination, rearrangement, and simplification. For finding, work measurement has been used to gather all the information to reveal the big problem. This allows us to better analyze the data from each workstation to understand cycle time. Line balancing techniques are then employed and labor flow are analyzed to overcome problems. For the work measurement, a work measurement is the length of time it takes to complete a general job task assigned to a specific job. Next is the line balancing. Line balancing is the technique, mean, and method averaging all production process and adjusting the workload so that the working hours are as similar as possible in order to eliminate the efficiency loss and overproduction of the imbalance between the jobs. That's all from me. Thank you.
Hi, I'm Kishan Gowda. My material ID is CD190326, and I would like to continue the presentation by the next chapter, which is methodology. First of all, if we take time study, the step 1 to obtain and record all information about the object, operator, and surrounding conditions likely to affect the carrying of the work. The step 2 is by recording the complete description of the method and breaking down the operation into elements. The step 3 is to converting the observed time to normal times. The step 4 is determining the allowances. The step 5 is the standard to determine the standard time for the operation. Followingly, the work measurement has been used to find out the different elements of the production process, find out the time taken by each element, and fix the standard time for performing the production by the process below. The first of all is historical data method. This is by using the past data to set performance standards and analytical estimating. This is used for fixing the standard time for jobs which are very long and non-repetitive. Last but not least, it is the line balancing method. The line balancing is a production technique that involves balancing the time and each machine's time to balance the production rate to tax time. The step 1 is to by creating a precedence diagram to show the relationship among those elements. The step 2 is to calculate the cycle time, which is the maximum time allowed for work at each station. The step 3 is calculate the theoretical minimum number of stations. The step 4 is to assign the work elements into various workstations. If there are 2 stations, choose stations that has greater cycle time first. The step 5 is calculate the line efficiency, and the final step is by calculate the idle time. So that's all from me. Thank you.
So I'm going to explain you about the result and data. Okay, for this actually we have calculated the um, normal time, standard time by using the um, different rating factors, and the allowance is the same, which is 9 for all the stations. And then we also have calculated the idle time. Okay, for this what we do is we have calculated the R, which is the idle match for the production planning. Okay, what we get is 0.328 uh, 13 liters per second. And then for the cycle time, which is for the maximum operation time allowed on each workstation, is 7. So for the line efficiency is about 93%, 93.75%. Okay, next. Okay, next we have manipulated data, which is the reduction of the original factor uh, by 50%, and the allowance is kept at the same rate, which is 9%. Okay, for this the R, the ideal match for production planning is 0.32813 liters, and then for the cycle time is 3. Okay, the maximum efficiency for 3 workstation is 109.3792%. Okay, for this actually the numbers is less than the original workstation, so maybe this can be efficient, but the bottleneck will still occur. So what we have done is we have added 2 more workstation. This may reduce the efficiency, but idling time will be also decreased. Okay, for the efficiency for the 5 workstation is 65.6275%. Okay, thank you. That's all from me.
Hi, I'm Kishan. So my part is I would like to discuss about the discussion in the slide. Okay, since the line efficiency is only about 65.62%, the corporation is experiencing a line balance loss, which is known as LBL. This is because the idle time of a few processes which result is an issue known as a bottleneck. The efficiency of this line is 0 when workload increases at a rate that exceeds the capacity of the production process. A bottleneck forms in the production system, such as an assembly line or computer network. Delays and greater production costs are frequently the result of inefficiencies brought on by the bottleneck. The term bottleneck refers to the typical shape of a bottle and the fact that its neck is the narrowest point, making it the most likely location for congestion that would delay the flow of fluid from the bottle. There are numerous ways to solve the bottleneck issue. One of it would be never let it sit idle. The bottleneck process needs to be continuously loaded to the capacity because it is steadily growing impact on the rest of the flow. The second method, we should lessen the load on the bottleneck to ensure that the task is delivered in the top condition. Third, the process must be operated in a group because some process would go more quickly if related work items were grouped together in batches. In any event, keep in the mind that risk increases with batch size. Smaller batches are generally preferable, but in the real world, we occasionally have to make concessions. So that's all from me. Thank you.
Hi, I'm Kishan Gounder again, and I would like to come up with the conclusion of this project. So the study aimed to identify the problems in production lines for small and medium-sized dairy plant and the effective way might be taken for the company to improve the productivity of batch-raised milk production. The work improvement techniques and proposed new machines for selected workstation extensions will help to balance the line and increase the productivity of the company as well as decrease the waste of cost in the production of the milk. We hope this research can provide a direction and method to improve productivity for other dairy plants. In the future, we hope to increase the milk productivity of small and medium-sized dairy plants through more research on milk production lines. So that's all from me. Thank you for watching this video. Thank you.